In this Grasshopper Voronoi Attractor, I want to show you with a simple algorithm how you can make point attractors on Voronois. And here you can see that I can define these point attractors, change the size of the attractor. So this is the first one, and this is the second one. You can also add more, and how you can increase the count. As you can see, you can increase the number of the Voronoi cells, and also change the position of the cells, and you can also define the number of the cells between those point attractors. So basically this tutorial will help you to understand a simple way of how you can produce Voronoi cells based on point attractors. Okay, to start the tutorial from scratch, first I want to say that the Grasshopper course members can also have another example which you can use the images as an attractor for the Voronoi cells. As you can see here, I can change them by changing this picture. So for the Grasshopper course members, they can also have this additional example. But to start from scratch, I'm going to go to the new document and go to the primitive, to the surface primitive, and use this plane surface to produce the base surface of the Voronoi cells. So let's just get started, and I will just put the Bifocals plugin so you can see the names, and we can give the X size and the Y size here. So we can simply just type a number here, and we can give this to the X size. Let's just make a copy into the Y size. So here we can have this X and Y size, and this is the base of the Voronoi. And if you don't know what Voronoi cells are, you can also watch another tutorial which I will put up in the cards section, and you will understand the basics. But in this tutorial, we'll also cover from scratch to the advanced section, so you will understand again how Voronoi works. So let's just go to the mesh section and triangulation Voronoi, or you can simply just type Voronoi. Okay, so this is the Voronoi 2D we want to use. We need a set of points, radius, boundary, and plane. So to produce the Voronoi cells, what we just used before was the populate geometry tool, and we give this to the plane, and you can see that we can define how many points we need in this plane surface. So if I give this point as the points of the Voronoi cells and the plane surface to the boundary, and let's just turn this off, you can see that you can produce those Voronoi cells easily. So the next step is to produce the point attractors on this surface. So what we need here is to define a series of cells which are more in this area which we want to define. So how can we do this? Because the Voronoi cells are defined based on points, what we want to do is to define a boundary, it can be anything, and then put additional points in that area. Okay, so this will produce more cells on that area. So again, you can make more boundaries and put points in that. So how we can do that? We can easily go to the surface and use the evaluate surface tool, give the plane surface to this surface. You can also watch the evaluate surface. I will put it in the card section, reparameterize, and use the MD slider. So if you don't know what reparameterize is, basically makes the domain from 0 to 1 and 0 to 1. And now we can give this MD slider to the points, and we can change this location of the attractor that we want to produce more Voronoi cells. So now we have the point here. You can see it here. So what I want to do is to go to the curve and draw a circle. So let's just draw a circle. You can also define anything. Any boundary is okay. So let's just define a radius. Give this a number. You can see that I can increase or decrease the radius of this circle. And we need to add more points in this circle. So if we just define the populate geometry on this circle, you can see that these points are going to be on the circle. And if we add these points with the shift key, I have the shift key and add this to the points, And you can also right click on the points and flatten them, so all of those points will be in the Voronoi section. You can see that this is simply producing more points on the circle. So if I just increase the count, maybe 120, you can see that this is producing Voronoi cells on the circle. But what we want to do is to produce the cells in the boundary. So any boundary, if you want to produce it in a text, assume that we have the text here, and maybe we just want to define a text. Okay, and just type in R, put this on the curve. Let's just scale this up. You can simply import these curves. Okay, these set of curves will be fine. And we can go to the surface, define a boundary surface. So this boundary surface will produce a surface which you can also use this as a populate geometry. So if I just turn this off, you can see, turn this off again, turn the curves off, you can see that those cells are in the boundary of a closed curve. So remember, you can always use a closed curve and then have a surface. If you have a single curve, you can simply give that to a surface. If you have multiple curves which you want to make a hole in it, just simply like the R section, you can go and use the boundary surface and then give this to the populate geometry. So what we want to do is to simply increase the number of the points and decrease the number of the points here, so we can see the difference. Okay, and now we can change the radius. Okay, I just went to 0, so let's just make this, the minimum is 1, and we can increase the number. So you can see how easy it is to change the location of the point attractor, change the radius, and if you want to give this more attractors, you can simply add another MD slider and with the shift key move that a little bit up, put that this corner, and again if we have to define another radius for this one and define another count for the second point attractor. So you can see how easy it is to add more attractors if you want, and you can also define the seed here. If I give a simple number, okay, we don't need this one, maybe just 256. It's not really important because it's a seed and it's changing the location of those random points, and you can give this another seed for those. Because there is two circles, we can define two seeds, and this will go for the first attractor and this will go for the second attractor. Okay, and at the end we can also make curves on that. You can simply have these cells, go to the curve section and use this explode, okay, to explode those polylines Voronoi cells into vertices, and we can use the curve NURBS curve here, and if I give this to the vertices, you can see that this is producing those curves. Let's just turn everything off. There's also a problem, I think, in one of those curves. It's too small, so you can't see it. Maybe here, let's just see that. And you can see that this is insufficient vertices for a curve, so perhaps there's a small curve which it can't show. We can also decrease the numbers of this to 200, 200, and this one to maybe 50. So you can see this is making big curves. And for the 0, you can see that this is also a vertices here. If you just connect a panel to that, to the vertices, let's just go down. You can see that there is a group of data which is empty, and you can simply fix that by typing clean and using the clean tree. Give this to the tree and give this to the output, and remove nulls, invalid, and empty. Use a toggle and set it to true to remove everything, right? Remove empty data and you will be good to go and don't see that red alarm. So that's not really important. And if you just look at those polygons, you can see that there is a problem at the end. And that is because the data, you can see that this is 7, but basically this is a 6-sided polygon. So it goes something like this. It goes from 0, 1, 2, 3, 4, and then it again put the last one as the 5. So what we can do is to go to the sets menu and use this call index tool. Give this to the list and remove the index 0. Okay, from that you can see that this is drawing, and then go to the periodic input and put it to true. Okay, so this is how easy it is. And now again we can just turn this off. The degree is 3, and I'm just putting that here. Turn this off again, and you can see that this is the results of that Voronoi cells on those boundaries. Okay, we can also scale them a little bit. Let's just scale the curve. The center will be the center of the polygon, so let's just make an area. Okay, we don't have the area for those vertices. We have to give an area to the cells. Here we have them. But remember, if I connect this to the center, what happens is that these data are in groups. You can see this. Let's just put that to simplify. There are 444, basically 445 groups of that, and this centroid is 450 points, which is simply those null things. It really doesn't matter. If I connect that to the center, you will see that this will scale everything. And that is because this is in groups and this is not in groups. So I will also put another video in the card section. Just check that out. If I graph this, we will have those points ready. But if you see, there are also some problems. So again, remember, you have to clean that. If you clean those polylines, you have to also clean this centroids, and we're good to go. We can scale that with a number, so basically 85%, and we can change that, right? And then we can just turn everything off. And here we go. We can also connect a curve from the params menu to this plane surface and use an offset curve, right? An offset curve section, so we can give this an offset distance. Turn this off. We can define the offset and combine both of those sets of curves in a boundary surface, and remember, you have to flatten, so all of those curves will be combined into one surface. Then you can easily extrude that in the Z direction simply by just 1. I guess that's fine. Let's just see that in Rhino. And you can see how easy it is to produce those point attractors. But if you want to change the location of the attractors, I prefer to turn off the boundary surface, change the location, right? Change the radius if I want, change the numbers. Again, we can change those seeds. And then when we are okay with the 2D, we can make that in 3D. So let's just turn this on and then bake the extrusion, because if you want to change the location, the extrusion is taking a little while to calculate. So you can see how easy it is to produce that and have this as a 3D attractor for Voronoi cells. For those who want to know more about this attractor, I will add another tutorial about image attractor, as I explained. For those who want to know more about the attractor, but as an image attractor, there are a lot of tips and tricks you have to know, because image is a little bit tricky. So I will add that into the Grasshopper course. So thank you for watching, and subscribe to our channel. And you can also watch something that is related to this video, that corner, and see you next time.